teachers, students, and researchers. I'm glad to be invited to give a report by EIA, the National Conference on Machine Learning and Intelligent Communications. My name is Xun-Wen, come from Heilongjiang University of Science and Technology. I am a professor in School of Electrical and Control Engineering. The topic of my report is Application and Practice of Artificial Intelligence in Heilongjiang Coal Mine Safety Monitoring System. This is my personal introduction. I'm Dean of Schools of Electrical and Control Engineering, Heilongjiang University of Science and Technology, and I am an expert of Heilongjiang Coal Production Safety Administration and Director of Force Concern of Information Branch of China Coal Industry Association and Sensing Province Coal Industry 千人智库 Skill Excuse. My scientific research President 9 project participate in 10 projects, have 5 immersion patients, 22 SAR EI searches, and the President obtained the third project of Science and Technology in Heilongjiang Province and third prize of Science and Technology in University in Heilongjiang Province. The participating season obtained the third project of Science and Technology Progress Awards of State Greater Corporation. Now I want to introduce scientific research history on coal of my university. Heilongjiang University of Science and Technology was originally affiliated to Ministry of Coal and has a solid research foundation in coal industry. Professor Wu Qingzheng, the director of the Electric Selection Department, developed a 250 kW and 2500 Hz serviced intermediate frequency power supply. In March 1978, he won the National Science Conference Award, the first National Science and Technology Award in the history of our school. The person on the right in the left picture is Wu Qingzheng. The right picture is National Science and Technology Award. Another person is Sun Hu. The team of the Professor Sun Hu of Schools of Electrical Engineering has completed SCR low frequency power support of Chengzihe main mine shift DC host electrical control of 2道河子 main new area. Belt electrical control system reform of Xiaohengshan main. Low frequency power supply of 2道河子 main shift. Belt converter electrical control of other menu area, electrical traffic system, reform of the domain, and this picture is a development and argument equipment used in the core. In recent years, the research team has focused on the new kinetic energy and the new development of the core industry, good by the National Intelligent Development, and applied artificial intelligence to the intelligent transformation and safety transformation of the core, providing scientific and technological support from the intelligent construction of regional core. Next, I will introduce the latest research and the application of Heilongjiang core safety monitoring in the Institute of Common Intelligence and Application of the School of Electrical and Control Engineering, Heilongjiang University of Science and Technology. And the following reports are divided into six parts. Firstly, its background, then solution, introduction to algorithm, and physical architecture, technology innovation. Finally is effect display. We will give special video of Heilongjiang core application. This part is background. In March 2020, the National Department of Reform Commission, Arms Bureau, and other 8 ministries. The commissions in joint issued the good option on accelerating the intelligent development of core. In July 2022, the Development and Regulation Commission of Heilongjiang Province issued the implementation openness on acceleration the intelligent development of core in Heilongjiang Province, which will promote the integrated development of intelligent technology and the core industry, improve the level of core intelligence, and improvement the high-quality development of China core industry. From this photo, we will see in recent years, although occurrence rate and death record of core accidents in China have been effectively reduced, but they are still higher than the world average. We can see from this figure, in 2050, there were 768 common accidents, and 588 workers dead. In short, the accident rate is still high. In addition to the common gas explosion we often hear, there are other factors that affect the safety of common production, such as complex underground environment. There are three factors. Firstly is objective condition. There was some objective condition in the industrial environment, such as poor lighting conditions, heavy dust, and intensive rest factors. As a result, the accident rate is still high. The second is subjective factor. Personal knowledge, the rules and the regulation. Illegally climb over the belt, illegally raise the belt, and illegally enter the zone. Workers have weak subjective consciousness, which leads to a high accident rate. Again, certainly is equipment abnormality, material accumulation, belt diversion, large foreign matters blocking the belt, abnormal operation of large equipment, car diaper, transfer placating. Equipment is prone to abnormality in complex environment. As for beacon treating solutions, real-time video monitoring. From this figure, we can see in a centralized control room, there was a large screen for monitoring downhole operations. The several personnel on duty watched the large screen in real time. But the problem is that the staff can't guarantee the video will all day. There was no way to respond to the fault in a timely manner. The current monitoring system can be used as a post-accident track method. The timeline operation before or after the accident can't be achieved. So it is a poor monitoring is common. The left is disadvantage of existing solutions. The separation level is closer related to the attention of watchman. Watchman fatigue easily lead to distraction. The personnel on duty have a negative attitude, stack and irresponsible, inaccurate hazard identification, and delayed response. The right is our work. Intelligent video monitoring and of personal and equipment safety. First is personal automated identification. Second is equipment status detection. The third is real-time intelligent early warning. Staff is easy to think of. When workers enter a problem, the response is delayed. Because of this so common, we have studied a method based on application intelligence. Autonomous person identification is mainly aimed at personal safety. Equipment status monitoring is aimed at the problem of abnormal equipment status and real-time equipment monitoring. Real-time intelligence early warning is able to conduct real-time early warning and equipment linkage to prevent further damage when personal safe and equipment problem occur. Personal safety and equipment problem occur. Intelligent video monitoring has 5 parts. Let's introduce one by one. First, automatic positioning of personnel. Intelligent positioning of seat personnel. Supervision area into the warning and the alarm signals set in real time. Second is device status detections. Real-time detection of whether there is material accumulation, fault diversion, rollable machine stuff, abnormal moving platform, like that the accident will eliminate in the path. The third is real-time intelligent early warning. According to the early warning alarm level, the sound and optical alarm and equipment link log to ensure product safety. The third is intelligent management platform. The last is multiple storage solutions. Next, I want to introduce two algorithms. First is real-time personal location algorithm. This is the development of target detection. Before 2012, it was a traditional target detection method. For example, the VG detector in 2001 can realize simple target detection foundation The Hawk detector in 2004 can realize face detection. It has further improvement in 26. In 2008, DPM method can also achieve target detection. These are traditional methods of detection. 2012 is a turning point. Alex Mark proposed deep learning-based detection method. Use GPU, graphics card, and a parallel computer to achieve accurate and faster target detection. Since 2012, target detection has been divided into two contexts. The one about is one-star detector. It is an end-to-end structure. The input is imagine and the output is a detector box. The following is a two-state detector. It is divided into two states. The first state is feature extraction, including preprocessing, and the second state is detect. The advantage of one-state detector is fast, but not accurate enough. The advantage of two-state detector is that it is accurate, but the calculation example is demanding and slow. This is the real-time personal location algorithm. Difficulty 1, poor image quality. Dust and smoke cover the target. This is the original picture. After demisting, we can see from the red picture. After defogging the magazine, the detector performance can be improved. Difficulty 2, high false alarm rate of single target detector algorithm. We found that router and other regions will be misinformed. On the basis of one-star detector, we add two classifications. We add benevolent to SSD. This is introduce SSD. This is a special algorithm implement process of SSD. This part is material accumulation detector algorithm. This is special algorithm process. The difficulty has been due to uncertainty of the call, including number call, motor call, This is a difficulty 1, 2, or 3. This is a process of materialistic detection algorithm. Let's look at 4 parameters. Alarm can only be given when the 4 indicators are met at the same time to prevent a false alarm. The third is a speed detector algorithm of typing machine. You can see this picture. The 2 balls are set at the edge of the car damping in the picture. This is my ROI area. When the disk rotates, the optical flow of the area will also change. So mapping the optical flow can be mapped to the speed, thus realizing the real-time detection of the car damp speed. The fourth is biometric detector algorithm. It will affect efficiency of production operations and cause abnormal damage to the equipment. It is easy to form. Firstly, imagine a question system. Imagine flattening, edge detection, and logical judgment. And this is relatively simple. It is detect the edge of the belt. If it can't be detected, it inducts that the belt has developed. The fifth is belt-less foreign object detection algorithm. We give a method dynamic background template acquisition based on Gaussian-Maxim model. This is a machine learning method. The last is transfer perform state detection algorithm. It is divided into 4 states: no track, on track no load, on track moving, and on track no load. The 4th part is physical architecture. There are 3 layers: hardware support, video stream content analysis, business layer. In the hardware support, have database server hardware database integration. In the video stream content analysis, its detection result, equipment status detector, personal identification detection, video stream. The first part is technological innovation. First is intelligent early warning system aiming at actively preventing accidents. Second is detection algorithm combining artificial intelligence with computer vision. The third is intelligent management system of monitoring video for factory environment. It can reduce manpower cost, reduce accident occurrence, prevent security. The last part is effect display. This picture is application case of intelligent monitoring of people and equipment in Hegang, Coleman. This is another picture. We can see from this picture is personal positioning. And this picture is material accumulation. This picture is speed detection. This picture is a large foreign metal detection. It takes in Xun-Wen core. This picture is status detection for transportable. Then there is display of the video. This is a process of personal position. This is a box made in the transport to prevent personnel from entering. The red box is an alarm area. This is prohibited from entering. The yellow box is an alarm area. When a person enters, they can detect and track in real time. The second video is a detection for material communication. The detection of material communication between bells and between bells and the coal bunkers is done in the underground. We can see that communication here, and then alarm function is realized. The third video is a speed detector screen, which can detect speed in real time. When the speed exceeds the threshold, it can be stopped in emergency. we can see another square. This is speed. This video is a large foreign body detection video in Xun-Wen. We can see that the large spring can be detected in real time and can also remind the material personnel to pay attention. That is in a red box. In a red box, a large object appears to give an alarm. The last video is a stated detection of transfer table. The current state is that no transfer table is found in the form. This is the state detection of transfer table. The current is that no strand is found. In the film, the state is no track. The track is not alive. Now it is alive and allowed detector, so the states become on track, on load, then start the traffic embedment and exit the vehicle. The start become on traffic moving. The car completely move out the traffic plant. The state become on load, no load. It indication that there's no load, so you can take the next car. That state is no track again. Okay. Now the above is the whole context of the report. Thank you for listening. This is my email. My email is ending.